All right, and here we are for Section 2, Week 3. Got the second video. We got second lecture video we're going to work on right now. And we're going to focus on the player game object. We're looking at around at like navigation. I'm sorry, not navigation, like the user interface, like screen space user interface, and the HUD. All these elements that are sitting out here. We're looking at the different scenes, intro, win, lose. Right now I'm in the main scene. We're looking a little bit in the game manager, not really at these major scripts, but more like underneath how these UI managers are working. And we did look at the world UI on the enemy turret. We did look at the VFX quite a bit. And now I have to talk about the player character. All right, so we have player input handler. We have player character controller. It's no problem. I was just saying I lost my video from Friday, so I have to go through everything again. So this will be on Section 3 quiz, and this is the last topic that'll be on the quiz. So we have the player character controller with a lot of properties being exposed out here. Some initial references to the camera, audio source. We have some general settings like gravity, ground checks, movement. So max speed on ground and air, acceleration, kill height. Just remember, there's no collider underneath this level. We're just always checking the height, the Y value of the player transform. And if it gets too low, we kill it. And the rotation speed. So this must be when the mouse was looking around. Actually, if you open up the player, we have this main camera that we're going to have to cover a little bit. Some of the rotation is being done here. Let me cover what's underneath here after we move through these scripts. So rotation, dealing with the character rotation based on your mouse. Your jump force, your stance, so how high the camera is. There's quite a bit of code setting that capsule. Remember, the capsule represents your physics collider. And it's not visible, but we are using this character controller, which does have a capsule collider as part of it. It's just unfortunately doesn't have a visualization to show you. Audio, so footsteps, frequency, fall damage you take. So we have a health script that we'll see if we get into this class. And then the weapons manager we're not going to get into. That will definitely be moving into next week. That's definitely a big script to look at. The jetpack, as far as I can tell, is not functioning. I might take a look at it, see if there is a way to get it functioning. So this is going to be important. So this will be our physics, our movement, and Unity has done a lot of work on first-person shooter character controller, so you can kind of use one that's out of the box and not have to do a lot of the core programming. It's an actor, remember, so on the game manager, there is an actor manager. So all the actors must get registered up here at start. And so all enemies and players are actors. It's like a generic term. And damageable. Are you allowed to take damage in some audio sources? All right, so underneath here we have the main camera. Basic camera component. And there's a lot of like rendering volumes, post-processing. We're not going to really get into it, but just makes it look nicer. Bloom, a light bloom. Vignette. If you just do Google searches on these, you'll see tons of examples. Tone mapping, motion blur, film grain, just to make it look cooler. So we have another camera, a weapon camera. It's not a standard render. If you remember, it's an overlay. And I don't even know if it's really being used that much, but it must have something to do with zooming or like sniper scope or something. So we have our first person socket dealing with our positioning. So we have default weapon, aiming weapon, down weapon. So when you're holding a weapon, when it's down, what's its position? When you're aiming it, when it's just a default hold. And here's where, when I click play and we start the game and it instantiates a weapon, it does it here in this parent socket. And here's some VFX for the jetpacks left and right, but there's no jetpack, so nice visuals, but we're not really gonna look at it. Aim point is where we're aiming the weapon. And this was a shadow projector, a fake shadow blob. So I was kind of talking about how real-time shadows are expensive. Anything real-time lighting is expensive, but real-time shadows. So if the scenery and a part of the level is static and it's not moving, casting its shadow is pretty easy, even if the light is moving. But when you have people running around, like dynamic 3D models, parts are moving and it has to cast like good-looking shadows. It's crazy expensive. So this is just kind of, I don't even think it's really active because I was looking down before, but it'll just cast like a silhouette, like just a kind of a little sprite, a little 2D graphic with a little shadow blob underneath you, just to feel grounded. And that's it. So player input. So it was sticking out of here. Look sensitivity, WebGL. So if you want to slow down how your mouse is moving, and inverting wire X. Sometimes people like to go in different directions, like up, like moving your mouse up will move your rotation down. But here's these properties that were exposed with the tooltips, what you could do with them. Pretty standard class. Here's it. Remember this M underscore are member variables. They're like private. These are the fields. In some conventions, this is how you later on. The reason I do this is later on in your code, when you're not looking up here, you can tell really quickly, oh, this is a field. This is a private variable being set to something. So it's just quick to read the code. So I was also talking about how on start and awake, you have to be kind of careful which component objects or registering to others or trying to access them because they might not be yet in existence. So the way that like when awake or start or update moves through all these game objects and all of their companion or associated component objects is it moves top down. So it'll move through here. There's nothing, move through here. It'll go through its hierarchy and then move on down and down and down. So like all of these managers like will get their awake run before the awake down here, and the same with start. So when you on start here, normally like on awake you might connect up. Like it's okay to say, hey, I'm aware of this other thing. I just want a reference to it. And that's fine to do like on awake. Usually do that on awake, and then on start, you know that like everything's kind of gone through its awake call, and you can start getting a little like you can dig into them. You can like call their properties or something because you know that on awake, whatever they were supposed to do on awake has happened already. So for example, here we're going out getting the player character controller and the game flow manager and setting up the mouse cursor. And on late update, it's just checking if fire input was held. So remember, there's update and late update, and all the component objects update methods must be run through before late update happens. So sometimes it's useful to make sure, hey, everyone's update was done. Now I'm gonna make sure I can do whatever I'm supposed to do in late update. So here we have some public methods that can be called by other objects, process input, get move input. So it's everything about player input handling. And if I remember correctly, it was this player input handler was like handling gamepads and keyboard and mice at the same time, or checking for either case. But get jump, down, held, So a bunch of firing. Are we just starting to fire? Are we just releasing our fire? Are we holding down fire? Same with sprinting and crouching and reloading. So basically, every action that is dependent upon player user input has all of these public methods here, and they're returning whatever the state is. So it's not actually running all these. The only thing it's actually doing is it does have a late update, which is run every late update, and it's just running get fire input held, and it's just storing whatever this is returning, this bool. It's just updating this one member variable. And this is just saying, hey, if we're allowed to process user input at this moment, let's see if we should be checking for a gamepad. Basically, get input, get access. Get access is used a lot with because you have like left and right, up and down on both keyboard and like gamepads. So an axis means like, okay, if you're holding a horizontal axis, means we can register any of the left or right within this number, and same with up and down. But this is reading, okay, if if the user is pressing whatever this game constant was for the gamepad. So here in another class file, we just have like all of our constants. Public constant string. We cannot a constant keyword means we can't modify this string. And so we have a whole bunch of names. So this is very similar to like an enumeration, but it is just listing out, hey, all these string names have this value. So for example, gamepad fire is going to be mapped to this string. Okay, so it's a bunch of like constant strings that can't change, and they're sitting by themselves, so it's easy to reference. Okay, but where does this get plugged into? Input get access. All right, and so this is where everything is going to be coming back for user input anyway. Everything's going to be coming back to this input manager that Unity manages for you because player input is very complicated. But here is like gamepad fire, for example. That string is referencing this. And this is mapped to joystick axis. Like we don't even need to understand hardware. We don't even need to understand like all the different gamepads that are out there. If the player plugs one into their computer or whatever device that's running your game and it registers a gamepad, Unity will handle everything for you. And whenever the player is like pressing left or right on that like left joystick pad, by this is 0 if nothing's happening. If they're pressing to the left, the number starts increasing to 1 and -1, and if they start pressing to the right, it'll start growing, towards 1. All right. So if you just want to check this, that's all that you have to do, and you don't need to worry about gamepads. So that's all it's checking. If this is not 0, meaning the user is definitely pressing left or right in some capacity, then this will be set to true. And if the user is holding down the gamepad, then we're going to return whatever this is, which is basically this again. Return if this is greater than or equal to the threshold. So you have to be careful with those type of like gamepads that are very sensitive to the touch. It's not either on or off. It's like you can lightly move them to the left or right, and they'll register a small number. So there has to be some type of threshold here. So trigger axis threshold is 0.4, which means you kind of have to be pushing the gamepad more like almost halfway to its full left or right for the game to register it as a move. And you can tweak these numbers to whatever you feel for your game. What about when there are more keys than there are buttons used in the game? Well, that's just up for your game logic. So I'm guessing you're talking about keyboard keys compared to gamepad buttons. Then that's just your mapping. Like if your game can be played on both a gamepad and a keyboard and mouse, but there's a lot of like shortcut keys on your keypad, on your keyboard, and like it's more robust to play your game on the keyboard than the gamepad, I guess is maybe what you're asking. Um, then that's okay, because you do your own mapping. So you say, hey, my game responds to gamepad inputs of like the movement left, right, up, and down, and was it like A, B, X, Y, in L1, L2, R1, R2, and um, and if somebody's playing my game with a gamepad, you see those games on Steam all the time where it's like this game is preferred to play on a gamepad, but we also support keyboard and mouse. Like it's more, the game might be more like actiony, more like more springy, more responsive on the gamepad, but the game might be more like a little bit more feeling, a little bit more tactical or strategic on a keyboard. You don't get like the responsiveness of a gamepad, but you have more choices on a keyboard to press. But that's fine. Yeah, you do your own mapping, so it's fine. If there's more keys in your game design doc, like you just in your whatever script is handling user input, you're checking for on the update loop, you're checking if the user pressed stuff. So that's up to you. So anyway, this get fire input held is just saying if the user is using gamepad, return like true if they're pushing more into sensitivity. Else return if the user is pressing down on button named fire, which is probably the left. Button named fire is fire. And then I got to go back up here and look at fire. And yeah, it's just mouse 0, left click. Just corresponds to left click, and that's it. But if you did want other like alternate positive, like if you wanted spacebar to be fire, you just type spacebar here, and then fire. This will also be true here. This will return true if the player's pressing spacebar. So that just I don't want to deviate too much, but this is why you have like little tutorials in the game before the player plays the game. You got to train the player in your input and what the game objectives are. So that's why it's like saying, "Hey, press spacebar or left click to fire your gun." You're telling the player what you already created in your code. Otherwise, if it can't process input, we return false. All right. So this is happening every late update here in this script, and it's doing nothing else. And then most of it's done here in the player character controller. These are my notes from last time where my video crashed, unfortunately. And as I was noting, that's just to me that's weird, because like that's like a little, it's like a little part of the update logic that's like sitting off on itself on another class, and so that would kind of screw me up if I'm trying to hunt around and figure out what's happening. So here on awake, the player character controller is going out and finding the actors manager, and if we did find it, we're going to set ourselves. We're going to call the set player method on actors manager and send ourself a reference to ourself in there. Above here is just a bunch of fields, and above that is a bunch of properties, but I'm not going to cover them right now. So on start, it looks like similar. We kind of go out, get me that character controller. Now be careful, we're in the player character controller, which is a custom script. Player controller is that character controllers that's slapped on to the game object is being provided by Unity. And then go out and get the input handler and weapons manager, health, actor. Looks like go out and get everything. And then go red. There is an event here. The health component object does have a Unity action, an event on die. And this is how you subscribe. You listen to an event. You say, hey, this is a method, a Unity action method. And I want to subscribe to it. Add my method onto it. So it's like my method will be called in a list of methods to be called when this event happens. And so on die, there was just some logic down here. So we're going to say, yep, we're dead. Basically, kill your weapon and broadcast out an event. So go to the event manager, which is sitting way up at the game object, at game manager. And broadcast is a method saying, pass me in the event you want me to broadcast. You want me to send out to whoever's listening. But the first step is people need to register and listen. Objects need to listen before they can receive a broadcast event. And which event are we going to send out? The player's death event. So this looks like an enumeration of some kind. And events manager is just a class that's in up on game manager. All right, so after start, I was kind of getting stuck in here last class for a little bit. I'm going to not dive into here because it wasn't really that interesting. But it's, should we set a crouching state and how do we update the character height? Which was like, it was like managing how high the camera is based on when we basically settle the character. We kind of let gravity take the, we're a little bit off the ground and gravity kind of settles our collider, and then we found a nice height for the camera. It was a little overkill, it seemed like. Anyway, update, very important. If we're not dead and our Y position is way too low, kill us. We have to go to the health script and kill us. If we jump this frame, we set this to false because it looks like there's some logic that is checking afterward if this should be set to true. Bool was grounded. Okay. So whatever this was, this is grounded. We're going to set it here because it looks like we're going to do some processing. So we're going to do a ground check, which is probably setting like what is grounded. And then we check, okay, this got updated in the ground check, and we already recorded what this was before we messed around with this. That's why it was. So if we currently are grounded and the last frame we were not grounded, that's what this logic is basically saying. So one frame ago we were not grounded, now we're grounded. Okay, that means we're landing. So calculate some fall damage, receive some damage, play some audio source. So this is happening every single frame. Now, input. So now we're going to the input handler and calling some of its public methods. Okay, is the user pressing the crouch input down in this current frame? If so, we're going to set that crouching state. And then it looks like we're always updating the character height. Okay, so with games where there's physics involved, maybe the camera starts getting janky and weird or something, and we have to like figure out how the controller is sitting on the ground, or like alleviate some forces or something. It looks like it's doing. Now I want to go back up to, okay, and then after that, handle character movement. I'm just going to look quickly at the methods. On die, ground check, handle character movement. Is normal under slope. Get capsule. Oh, okay, right. We were doing the capsule collisions, right? Update character height, set crouching. Okay. It's a lot of lines, but ultimately it's more about movement, player input, physics, movement. So this is happening every update, and my argument was that this late update here, like this should just be calling this and setting this, like if that's what they want, but you should really be doing it over here. But void handle character movement. So first, it looks like we handle horizontal character rotation, like left and right. So basically it's saying, okay, we're going to rotate the character's transform, and how much are we rotating it? So it looks like it receives a vector 3 in Euler angles, all right, 0 to 360. So we're creating a new vector 3. And we're not rotating on the X or the Z. So if I just take the player, if I look out and I just rotate it on the Y, this is a horizontal rotation. All right. And what we're doing is we're going to the input handler and get look import inputs horizontal, whatever this returns. So let's just take a quick look at it. So return get mouse or stick look axis. Okay. So we're going to pass in the mouse. So the game. So however, the movement of the mouse left and right. Not this is the mouse going forward and backward. This is the mouse going left and right. It's just the horizontal axis. We're just interested in how much is the mouse moving left and right during that frame, which can be 0, nothing, or it can be left or right, negative or positive. And also pass in the joystick look. So if you're pushing the joystick left and right at all. So this is another method. So if you can process the input, or is it the gamepad? What's interesting? Let me cover it just because we talked about the ternary operator last time, so I'm going to cover it again. So this is saying input get axis, whatever we pass in here, which was joystick left and right. If it's not equal to 0, then this is going to return true or false. So this is like a logical condition. And it's going to return true or false. We're passing it into a bool. And so if the user is pressing left or right at all, this is true. Okay, so what happens here? We say float I is going to equal, and then we do a logic. The way this ternary operator works is we're saying there's some bool variable or expression here, and we're saying, okay, ternary operator. So if this is true or false, so if it's true, I is going to be equal to this. If this is false, I is going to be equal to that. So remember, this is true if the user is using the gamepad, basically. So if this is true, we're going to go pull in whatever the value is from that gamepad. So it's not 0 because we just checked, and the user is pressing it. So it's going to be some value between -1 and 1 for left and right, but it won't be 0. And if this is false, that means the user is not using the gamepad. Then we're just going to pull in this, which is the mouse moving left and right. So the raw value of the mouse moving left and right in screen space, which again will be values between. I don't think it'll ever get. No, we'll get bigger. Basically, it'll be small values and then negative to positive. Small values like 0.01, negative 0.01 and stuff. And so this is called the ternary operator. So if this is true, we pass that. If it's false, we pass this. And they get put into here. All right. It is the inversion. If we're inverting the y-axis and applying a look sensitivity, sure. Invert it or just multiply by sensitivity. If it's the gamepad, okay. So if it's the gamepad, it's just going to be a number between -1 and 1, but we multiply it by delta time. So delta time is just a little, however much time passed since the last frame, which is just going to be a little fraction of a second. Usually it's like 0.2 seconds, 0.3 seconds, 0.1 seconds. So what that does is it makes it time dependent. So it's like, okay, we have this value that goes -1 to 1, but we don't know how much time has passed since the last frame. So we just have to multiply it by that length of time because they're saying that the mouse input is already has already been adjusted for that, but the mouse input is like needs to be shrunk down. Like it's not that same nice like -1 to 1. I guess it's reducing. All right, so the mouse input left to right, the numbers are going to be higher. I guess they're returning like how many pixels was crossed left or right. I was thinking it would be in screen space coordinates, but it's not. So anyway, fine. We're multiplying it down by a little value to shrink it so that it's the same type of momentum size as the joystick. And then we're just returning that value. Okay. And all this goes back to here. So it's like, what is this value coming out based on if the user is using a gamepad or keypad controller, keyboard. And then whatever that is, we multiply it by rotation speed and then by this rotation multiplier. So it's pretty common. So the time has already been taken into account. So that time dot delta time has already been multiplied into there, which is common. And when you apply movement or rotation to a character from user input, you'll usually see it's like time dot delta time. Basically, it's variable. You don't know how much time has elapsed from frame to frame, so you can't just apply like a constant number because it'll be irregular from frame to frame. So if you multiply it by that time dot delta time, it'll make that number like incorporate that irregularity from frame to frame, which will make the number regular in your math. And then if like the number's coming out too small or too big, you just mess around with this rotation speed factor or this multiplier to get it to where you want to get it to. And then lastly, you got to put it into whatever coordinate system. So it's like local space. It's not being applied to global space. Like it's going to be applied whatever this number is. We're not considering well, it happens to be sitting. It doesn't matter in this case, but if the game object was down in the hierarchy, and it has some local space, some translations above it, then it'll matter. Okay, that was horizontal rotation, and then vertical rotation. Basically, it's all the same thing, except it's a different method called we're looking at the vertical axis, up and down. But all the math and logic will be the same. And then what we're doing is that we're adding it to this camera vertical angle field and then clamping it. We don't want to go too low or too high. And then we're going and getting the player camera. And here, notice it's local rotation. And we're doing something similar, but we're rotating up and down. So we're rotating on the X. So we're rotating like this. All right, and so it's like we can't go more than, it was like -89. You can't go like you're like breaking your neck looking like that. So that's why it's clamped. It's clamped up to here, and then it's clamped down to there. So you can only look like straight down to straight up, and it won't let you go further. And so this is how we're getting this horizontal rotation on the player's camera. Okay. So they probably didn't want to rotate the player's the player game object up and down because this is like this is where you're aiming and shooting. Or no, it's probably messing up like the physics. Yeah. So if you remember, there is a capsule collider. And let me just move this. I picked the cylinder, but same type of shape. So there's a collision thing like this, and they're constantly checking and seeing if we're grounded, this and that. So you don't want to rotate this thing because look what happens when you rotate the player. It's messing up the collider. See that? So if you rotate the camera up and down, we get we're looking around feel, but we're not screwing up our physics, our player collider. And so we can aim our gun and we can aim where we're looking with this without messing up our physics. And the only rotation we're applying that's messing up, that's yeah, if I just zero out the position, it put it dead center on my game object. And if I rotate it on the Y, this is what we're looking around like this. And the physics is capsule is staying like dead straight. All right, so that's probably why they separate. That's my guess why they separate at the rotation. So I stopped here last class, but I didn't hit upon the dot product, which is weird. So I must have been looking through. Okay, here's the dot. Oh, the ground check. So basically, this was looking at the normals of the ground and the normal of us, and doing a capsule cast, like casting down our capsule collider shape and seeing what we're hitting when we cast down and see what the ground is like. And then we're checking the dot product here. So let me just show you why that's important. So I was kind of doing this with doing like a cube. Yeah, well, the dot product is a vector operator, and a normal happens to be a vector too. So we do a lot with floats, decimal numbers, vector twos, which are just two floats, x and y, and that helps us do easier math in 2D coordinate spaces. And then vector threes are x, y, z, three floats, helps us do math in 3D coordinate spaces. And so a normal is actually a vector. And so let me just fit. So let's just assume that this is like a vector and line. And let me just draw need something on top of it. Hold on one second. Let me just build this thing. Then we can cover the cross product. So let's just assume the sphere is like the direction. A vector is like a line, like a distance, like a length of magnitude, but it also contains a direction. So here we're saying this thing has a length of about 2 meters. I'll just make it easier. Just make it 2. It's a 2 meter line. 2 meters is about 6 feet. So it's a magnitude of 2. Oh, sorry, no, it's not. It's just a position. So it's actually a magnitude of like, let me say 3. Okay. So this is, I'm sorry, it's a magnitude of 3. I scaled it 3. So this is like a 3 meter or like a 9 foot magnitude. It's like saying, oh, we're moving at 3 meters 3 meters a second, 3 meters a minute, whatever your speed is. So it's like saying we're moving, let's just say 3 meters per second. That's pretty normal convention in physics. But it's like saying, hey, that's great. You're moving 3 meters a second, but in what direction? So a vector signifies the magnitude, 3 meters, and we just happen to cover it in 1 second of time. And it's also covering a direction. So that's great. We're in 3D space. What the hell does 3 meters mean? That's just a speed, like 3 meters a second. But if you're saying the direction is like 0, 1, 0, we're moving nothing in the x, nothing in the z, we're moving all in the y. Then we're saying we're moving up. We're moving 3 meters in positive y. So So the normal, when we talk about geometry, we talk about polygons. Each face or each vertex can have, each of these like little triangles has a normal, and that's how it knows like what its orientation is. Like it's facing up. The normal is perpendicular, shooting out of the surface. And that's where, like, when we calculate lighting on a geometry polygon, and it's like how much of our main light source is hitting this. Notice it's darker on the walls over here, but it's lighter here. Well, that's because we're using a big directional light that's aiming mostly down, and we use like the normal vector of the light source and the normal vector of the polygonal face to figure out how much they're in alignment with each other. And that's how much of the light that each polygon face should receive. So this is the normal of the floor. It's pointing straight up. And normally we use unit size vectors like 0, 1, 0. It's a magnitude of 1, and it happens to be pointing directly up. And so imagine this is the player and this is the floor, and it just so happens we're both pointing up. But imagine when the player gets over here, and the player just happens to be always, we're not messing around with the other rotations, so the player's always facing up. But what happens when the player gets here and is standing on this ramp? Right about there. Well, the ramp normal is not perfectly going up. The ramp normal is something more like this. And so we're not in perfect alignment. We're not standing on flat floor anymore. This might be something more like, it looks like based on the red line of, we have some like angle going on in the X and some going on in the Y. So if it was a unit vector, and like the normal pointing out of here as a size of a unit vector, maybe it's like 0.6 or like 0.4 in the X and like 0.6 in the Y and like 0 in the Z. We're getting no zero. We're getting no Z. But this unit vector is aligning, like is coming off in the X and the Y. And if the ramp was going the other way, like this, this has no X, but it has Y and Z, if the ramp was doing that. But this is how we tell the differences between vector alignment with the dot product. So if they're in perfect alignment, we do get a 1. And so anyway, what I was, just to wrap up the last one, is that all normals are vectors. And when you have them in perfect alignment like this, just even though these vectors have a different position, we're only concerned about their magnitude and their alignment. So these are aligned perfectly, so that means their dot product would be 1. And if they're aligned perpendicular, like perfectly perpendicular to each other, it's a 0, even if it's this way. Basically all of this type of like 90-degree offset or perpendicular offset, all of this would be like a 0 because they're all like 90-degree line from each other. And if they're perfectly opposite each other, that's a -1. And so we have numbers ranging from -1 to 0 to 1, and in all of like the 3D rotations, you can boil it down to between -1 and 1. That's super useful to figure out like a quick alignment with surfaces and characters and stuff. That's how they tell, like, is this character facing me right now? How much normal? Like, an enemy might be watching, like, what's my distance? The enemy AI that works a lot is how far am I from the user at this moment. What's the magnitude of distance? So this would be like a vector, but we're just interested in the magnitude. How far away is the player from me? And then the enemy is usually facing a certain direction. And then we use the dot product there. We say, based on how the enemy is facing at this given moment. So let's just say this represents I was looking for world and local orientation because I look gizmos and local. But anyway, so let's just say he's kind of looking this way. This is like, so the angle, the vector of his rotation is over there, but the angle of the two of us, the angle of our orientation to each other is going to be something like this. Right? But he happens to be looking over there. And if we took the dot of these, it's almost like a zero. They're almost at like 90 degree, right? But as he's like patrolling, let's just say he's patrolling and he's slowly moving, and let's just say this dot product gets to something like 0.7, 0.8, and then we're like in the AI logic, like, oh, I can see, the distance is close enough, and my dot product between where I'm looking, where the player is to me, is greater than 0.7. So go into like alert mode and run at the player. So that's how a lot of the vector operations are used like that: magnitude and dot product. The cross product. So the cross product is more complicated mathematically. It's more expensive. And what it's doing is it's finding, if you give it two vectors, so in this case, the right-hand rule probably is easiest to look at. So let's just say we give it A and B. The cross product tells you what is the axis that's shooting off of the others, perpendicular to the other two vectors. Now, the other two vectors don't need to be like perfectly perpendicular to each other, but if you give any two vectors, you'll be able to find like the third vector that's shooting out. So it's used in 3D, and I believe I may not be correct though, but if A and B like are perfectly aligned to each other, they're sitting right on top of each other. It's like, I think it's impossible to figure out what's perpendicular to that because there's no offset between those two vectors. So I think you'll get some like crazy like infinity or zero or something. I think there needs to be a slight difference between A and B. I mean, a perfect alignment is you give it the x-axis and the y-axis, and the cross product will tell you the z-axis. But you don't always have these perfect alignments. So basically, it's saying, where is this third direction off of these two vectors that I'm not really covering it in class right now, but it is it does come in useful, but in your stage right now, the dot product is super useful and a lot more easier to understand. So it's the use case for cross products. I mixed it up. This can be used for the normals. Correct. So if you do look at like one use case is if you look at a polygonal face, right? And if you do happen to know two vectors on the polygonal face, this triangle, which you do, you have three positions, right? Three vertices, and they each have a world position, an XYZ. You can create two vectors. You could say, okay, from this point to that point is a vector. All you just do is vector subtraction. You subtract one vector. A vector can represent a position, and it can represent like an orientation. They're like really versatile, but it also is confusing. So you can use in this case, I'm using a vector to give me the the distance. Like, what is the difference from this vector, which is a position, and this vector, which is a position, but the difference between them would be a direction, like a magnitude and a direction. So imagine just, I don't know if the screen sharing has, oh, it does have annotation. I'm not sure if you're going to see this, but no, the color kind of sucks. I don't know. Can you see this yellow color? These yellow dots? It's the annotation tool. Somebody could just say something. Barely. Yeah. B and A. Hold on. Let me just see if there's settings or something. Nah. It's kind of weird if they give you annotation tools, but they're like really light. Either case, there's a dot here and there's a dot here, right? Those are positions. If you subtract one from the other one, you'll get a direction. That's an arrow. It's an arrow going from this point to this point. That's the vector saying what do you have to do to go from this position vector to this position. And then if you subtract this one from that one, you get another arrow. That's two vectors. We have two vectors lying along this plane in 3D space. So if you cross product them, you'll find the vector that's coming off of them, perpendicular. This is hard. It's going straight up in this case. But yes, using the cross product, you can find the normal off of a polygon. But don't worry about the cross product. Focus on the dot product. The dot product you'll use a lot as a game developer. The cross product comes in a lot more deeper down the kind of rabbit hole of 3D programming and computer graphics. But if you remember, the ground check was shooting a capsule down like a ray cast, but a capsule cast, and it's just a difference between like a line and a shape. It's going to hit something. What are we going to hit? We're going to hit the floor underneath us, so that this hit value comes out. This hit object, in part, one of the properties is the normal of whatever it just hit. And so we store that, and then we do a dot. We say vector3 dot. It's a method. And what are we going to pass in? Well, whatever we just hit, give me its normal, and do the dot on that compared to my transform dot up. So these are shorthand ways of saying what is the up value of this transform. So you have to be careful when it says the transform in the green axis of the transform in world space. It's like saying after it's been rotated, what is the local space of the up? So you have to be the words, the verbiage is a little bit. So if the player, it kind of sucks that the player doesn't need graphics. So if the player is standing up, this is kind of perfect here. So if the player was rotated, in this case, let me just do something simple. It was just rotated 15 degrees in the X for whatever reason, right? Notice how the green arrow, the local up, is a little off. It's not like world up. So when I say transform dot up, it'll give me what is this green arrow in respect to like global up. So it's not going to be 0, 1, 0 because it's slightly kiltered. It looks to be kiltered in the Z. So it might be like the transform dot up after it's been rotated like this might be something like 0, 0.8, and like 0.15, or whatever those numbers come together and get a magnitude of 1. You have to be careful because a magnitude is that distance algorithm. It's like x squared plus y squared plus z squared. Take the square root of that. So it's not like adding them up. Like it's not like, oh, y is 0.8 and z is 0.2 and you add them up and that's 1. You have to do that kind of distance algorithm to figure out a unit size like what a mixture of values would equal a vector magnitude of 1. Anyway, this is like transform.up. It's not perfectly up because we rotated it. So that's what it's saying. So if you take these two vectors and take the dot product of them, in which case the player will more normally always be up. It's the floor that will usually be up, but if you're going on a ramp, it'll be angled a little bit. Or if somehow if you do some type of jump or some craziness and you get pushed against a wall and maybe you're shooting down and it's like looking into the wall or something. But as long as this dot product here is greater than 0, meaning they're not perpendicular, which would only happen if you're looking down on like a wall surface, and whatever this is normal under the slope limit, which we looked into this last class and it like almost does the same math. But whatever the slope limit might be, whatever the angle between my up and what's on the floor is up. So the angle is another the angle difference. So it's like saying, oops, very similar to dot product. Like if you have two vectors that are the exact same, the angle difference between them is going to be 0. So the dot would be 1 and the angle would be 0. And if you have something where they're perpendicular, the dot would be 0, but the angle would be 90, because there's a 90-degree difference between that. Even something like this is still like a 90-degree difference, because it's like doing that. And it's saying, oh, that's 90 degrees. So anyway, they're like, get me the angle between the two is less than, it's like doing the same thing as the dot product. Cool. So here we were wrapping up ground check and blah, 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 blah. If the distance, so this was snapping. This was like, okay, I'm dropping. So whatever the hit, like the floor underneath me, whatever the distance is to it from me, where I shot my raycast out, if it's greater than the skin width, so the controller has like a little skin with a small value, like a little buffer zone. We sit on top of it, kind of like a virtual skin. But if we're higher than that little skin diff width, we just take the controller and we move it. We do the move method, and we say, okay, how much are we moving? Well, we take the down. Vector3.down is global down. So it's 0, -1, 0. You could just say new vector 3 and write it out, but it's longer. And multiply it by how much distance do we have to move. So this is a vector times a float. So all you do is take the x, y, and z, multiply each by that distance, and it's only -1. Only the y would really get impacted. And then we'll move it that much down, and we'll sit on the floor. That's a snapping. That's why they call it a snap. Cool. I'm just going to think real quick. I'm not going to try to do any new features. I'll think about this next week. I just want to make sure that I didn't miss. If somebody remembered something I was talking about last Friday and I didn't cover it, if you could just let me know. In the meantime, yeah, somebody was like, how do you do a double jump? Because we were kind of talking about, that's something. I was talking about how you'd approach a double jump. This is something that might be it would be a lot easier to do in a platformer, because the logic here with the jump is crazy. But what you would do is you say, okay, first off, the player's in different states. And so you'd have to see, where are we handling, like, when are they grounded or not, basically. So let me just talk about the basics of a double jump. So normally it's like the states of the players, like, are they grounded? Did they just jump? Are they jumping? Are they landing? And are they grounded again? You can have other stuff like are you crouching, are you running, are you shooting and stuff. But as far as like the states to manage a jump, now if the user presses, we're checking for input, and usually it's like spacebar to jump. So we check. We say, hey, player input manager, did the player just jump or press the jump input, which is the spacebar? And if that's true, then we can check. So it usually is done in the update loop. And if we do jump, that just made me check. That just made me think. Where is this happening? Handle player movement. Horizontal rotation, vertical rotation, sprinting. Apply the final calculated velocity. So move based on the character velocity. Okay. So it is sprinting. Oh, this was not just about sprinting. This is like all character moving. Okay, let me see here. If you're grounded, okay, world space move input handler, get move input. Okay, vector 3, get raw axis on the X. So this is like AD left, right. Get raw axis on the vertical. So this is WS up, down. So this is grabbing the X, like left, right, the Z, forward, backward, and nothing for the Y, no jump. And then slapping that into this move, clamp it, return. Okay. So this is just handling like left, right, forward, backward. And then if you're grounded, target velocity, figure out your target velocity. If you're crouching, I can ignore that. Smoothly interpolate between our current velocity and target velocity. Vector 3.lerp character to target. Okay. So I guess it's like I guess if you're pressing down on a movement, it doesn't want you to like jump into like feel jarring. There must be like a ramp up and down in the acceleration. Here we go, jumping. So if you're grounded and our get jump input down just happened, then force the crouch state to false. So cancel out the vertical component of our velocity, okay, which I don't even think was happening to begin with, but sure. And then add the jump velocity. So this is a vector 3, add into it another vector 3. So vector 3 dot up. So 0, 1, 0 times our jump force. I think it was just like 40 or something. 9. Okay. So it'd be like 0, 9, 0. When you add the two vectors up, there's nothing in the X, nothing in the Z. We're just adding in some Y. So play some audio. And we're saying the last time that we jumped is whatever the current time is of our game run time. And we did jump this frame. And grounded is false. And we're not grounded, and we're figuring out the ground normal is we're just setting to a default up for whatever reason. Okay. So we know that if we're grounded and there's a jump, we're going to do this. Now, we could just slap in, so those are kind of the states I was talking about. Now we could say that we can add another state like bool, I don't know, is first jump. And we'll set it to false. I'm trying to think of, I'm going to have to reset this wherever. Hold on 1 second. has jumped this frame. Okay, here we're landing. So here's a good place when you landed. We're not in our first jump. Okay, I just need a way to reset this, so this might work. So let's just say we're not in our first jump yet. So we're grounded. The options here are like we're grounded, we're in a first jump, or we're in a second jump. And so first jump is false, we're either grounded or in a second jump. So we know if we're there's already a variable for if we're grounded somewhere. But it's right here. Is grounded. Okay, it's up here. So what we could say is if we're grounded and we weren't grounded last frame and we're landing, here we're landing. So we're gonna say is first jump. We could just set that to false. Like we're not jumping anywhere. We know that this happens when we landed. So boom, we could just like reset this thing. All right, and then in the update for handle character movement. Okay, so here, if we're grounded, there's a bunch of stuff going on. And if we're grounded and there's been jumping, we can jump. And then I could do another, I'm just going to do another check here. If, yeah, it's fine, we can take that. And if we're not grounded, so if we're not grounded and we're in a second, we're in our first jump, something like that, and the player has just requested a jump, we can do something. Now there's something I got to set here. So if we're grounded and there's a jump, and we're not crouching, here we're actually doing a jump. So I'm going to say we're in our jump at this point. And if we're not grounded and we're in the middle of our first jump and the player's requested jump, I'm going to add some more jump speed to us. I'm just going to do this. So I could do, I don't even know if this is going to work, but I could do more logic. Like usually they wait, like, okay, if we're in a first jump and it's been a third of a second, you still haven't, like, at least you've left the ground and there's some amount of time, then you're allowed to like execute the double jump. But it's fine. I'm just seeing if I can get anything working at this moment. And I guess I kind of lied earlier that I'm not going to implement anything new, but this seemed to be rather quick if it's going to work. Whoa. Okay, it's giving me it's giving me all the jump force together. So it's input if it's down. I don't know. Wait. Returns true during the frame that the user pressed down. Oh no, that is what I want. So if we're not grounded, this is where you might want to take, yeah, I might want to wait a little bit of time. If we're not grounded and we're in our first jump and jump is, and the character just pressed, I'm going to just do another if just because that one's getting kind of long. But if something like if time minus like the last time we jumped is greater than like 0.2, basically like if at least 0.2 seconds has passed, then you know why also, because if this happens, then we set this to false because we don't want, I'm allowing jumping. It's like it's kind of weird. It's supposed to be get jump input down. It's supposed to only return true right when I tap it, not while I'm holding it down. But it seems to be giving me like all my jump force at once. So let me try that. If this minus that is greater, okay. Then we're gonna add and then this. Let me just comment this out real quick. Let me see if I can get just like some jump spamming going. Oh. Seems like I had, oh yeah. There is like a second jump happening. Or it's like this weird, I am getting like a little boost. If you're not grounded, and this is true, and this is happening, okay, let me just ramp it up a little bit just to see. I don't know if gravity is like really coming down on me and I'm not really seeing it. Anyway, I'm just going to be doing this for a few more minutes, and that's it for the lecture. So if you want to head out, you can. All right, I'm going to put some debug statements in. See what's happening. First jump. Let me see if I'm getting in here first before I start moving it down. Second jump. The second jump is happening like right away. It is okay, so that helped me. So this becomes false right away, and then this becomes true, and so actually this happens right away. So that's okay. But that's why, that's why you need a little bit of a time delay. So I am going in there. But I'm not going, because if, what am I in? Oh, because of here. To doop. So if grounded. So I can't, I gotta pull this out. I'm in a bad area. It's gotta go here. I'm just gonna, it could be before or after because this is gonna happen in another update loop. So, okay. If you're not grounded and you're jumping, and the user's requested to jump, and it's just been 1/10 of a second since we first jumped. Let's jump. All right, I got a feeling this is going to work, so I don't want to have such a massive boost. Whoa, awesome. Way too much. It worked. Awesome. All right, so let me get rid of my debug. Let me ramp down this jump force. Let me get rid of the debug that's down here, and then I'll go over what I did real quick. And I'm I'm going to end lecture. Cool. Jump, jump. And I can't do it. If you wanted to, you could do triple and whatever, but I just did a double jump. All right, it works fine. And if you didn't want the second jump to be, as strong, you just like multiply it by 0.5, or if you want it to be stronger, you just add some simplification to it. So what did I do? I added another field. You probably could have entered into enumeration like different grounded first jump, second jump, but I just said, hey, are we in a first jump or not? That's all I really care about. Bool. Now I got to be careful where I'm setting it. So here you're landing. When you're landing, this needs to be set to false. Like I'm resetting. You always have to reset your situation. So when you land, reset. We could try again. Now, next is when do we actually jump? Is here. We're grounded, and then if we're grounded and we want to jump, let's jump. So this is when I say, okay, fine. We entered our first jump. And then I had to make sure I was out of this because that was an issue. So now I can say, okay, the next time we're kept running through these update loops, if we happen to not be grounded and we're in the middle of a first jump and the user has requested jump, we can do it. I just did a time check. Time since the last jump. As long as like a tenth of a second or something's happened since we left the air the first time, I'll say fine. We can go for it. So take the velocity, add another jump force on the up, add it into our vector 3 velocity, and say we're done. I guess there should be. Yeah, we left. That's correct. We are not in our first jump anymore. We are now in our second jump. And then we can only second jump. And then we have to return back to the ground for this to become true. And we have to leave a ground again for this to become... I'm sorry. Yeah, we have to leave the ground. We enter the ground. This becomes true. And then we're allowed to initiate a first jump again. And then this becomes false, and this becomes true. And then we are, if the user wants it, we are allowed to do a double jump. Cool. All right, I'm going to stop video recording, make sure my video is good.